and welcome to another edition of Lunch and Learn with Vince. I'm your host, Vince Marino, and I got a really good friend that I've known for a long time. It's Mike McClurg. He's the president of Load Controls. Mike is an avid golfer and trail runner. I see that your intro says bad golfer, Mike, but maybe you can just tell me, do
Yeah,
you like golf when you're playing it, and then you just can kind of put it down and, you know, because I'm not a great golfer either, so I love that intro.
yeah. I didn't set out to become a bad golfer. Thought I would enjoy the game, and I do like to play, but for somehow it's just come about that I'm able to maintain a very consistent level of bad golf. And it's really independent of the amount of time I put into it or love that I show for the activity. So
Yeah,
I think that's just what I'm destined to be. But
I hear you.
good way to spend some time outside.
Right, but in spite of being a bad golfer, you're very good at the load control industry. How long have you guys been in business? Tell us a little bit about load controls.
Yeah, so Load Controls was started in 1984. My dad, Bill McClurg, and an engineer, Bob Nystrom, split off from another company that was developing motor power controls at the end of '83. So we're just coming up on our 40-year anniversary here at Load Controls. Always been here in Sturbridge, Mass. This is the third location that we've been in. And we've always been in the motor power control and sensor business since the beginning. Some of the applications and products have certainly changed over time, but yeah, that's the business. Almost 40 years.
Wow. And I worked with your dad in the past, so 4 years is quite an accomplishment. And I'm looking at the new facility in the background there. If I'm not mistaken, isn't that a real world pumping environment that you have now at your headquarters? Do I have that right?
Yeah, that's right. We have a partnership with University of Massachusetts Amherst. They have a group there that's focused on water and energy and technology. And we contracted with them, and we've been working with a few of their researchers and some of the students there. We built this environment last year, got it installed at the beginning of 23, and we've been really testing our products in a real world environment. We've got some pumps from some of our pumping partners, and we'll talk a little bit about it. Part of what we're doing is breaking motors and pumps and seeing what that means for the electrical data that's flowing back and forth, and we'll talk a little bit about that. But it's been great to have it here. We've got it instrumented with a bunch of different sensors. We've got our own power sensors, a couple different ones in here. We've got pressure sensors, flow sensors, vibration sensors. We've got some valve restrictors that we can change the pressure in the environment. And it's been a lot of fun for our engineers to be able to get some real world data about how our products are used in the pumping world and what happens when things start to break.
Well, okay, so just take me from the very top. I mean, what what are the products that Load Control offers? And feel free to, if you have photos that you want to share, super casual. So if you want to stop and grab a picture or whatever you want to do, or just point to, there you go.
Yeah, let me share this with you so we can talk a little bit about this we talked about. We're in Sturbridge, Mass, been around since 1984. We've got 11,000 customers, a little bit over that, and over 150,000 of them installed.
Amazing.
And
That's
yeah,
amazing.
it is.
Unreal.
So what our products do is you connect the electrical signals that go into a motor to our products, and we're able to get the voltage and current. We multiply those together and get the power information. So exactly the horsepower that motor is consuming at any point in time. And that ends up being useful for three different things. The first one is protecting the motors and the attached equipment. And in most cases, that's a pump. So when we are able to tell how much horsepower a process is using, a pump is using, we can tell when power goes up, that may mean some bad things are happening. Things are clogged or jammed, or there's something impeded. Or when power goes down and there's no fluid going through there, that could also mean bad things like cavitation, dry running, maybe a broken impeller. So the primary use case of our products is to protect the motors and the equipment that they're attached to. So whether that's pumps, conveyors, we're used on conveyors, mixers, and machine tools. So if a grinder or something that's removing material, the tool gets dull or it breaks, we're able to detect those types of things. So protection has been the primary use case for load controls. The other area that we're used a lot is in process optimization. So if you connect a load control to a mixer, you can tell when things are starting to change viscosity. So you might have ours connected to a waste treatment facility or connected to a food and beverage processing mixer, and we're able to tell not only when the motor is in danger, but also when the processes are changing and viscosity is changing as well. So that's sort of the second thing. So protection as well as optimization. And then the most recent area that we're seeing more of our products being used for is in the area of energy management and just really understanding how much power the motor is using that's driving a process, and is that the right size motor? So we hear a lot of conversations in the pumping industry about, are the motors that are in place the right size for the amount of work that they're doing? And just by simply comparing the horsepower that we're measuring that the motor's doing with the size of the motor, you're able to tell very quickly if you've got the right size motor for what you've been doing. So our customers look like large process manufacturers. We say 9 of the 10 of the world's largest pharmaceutical companies, 9 of the 10 largest chemical processors use our equipment, paper, pulp. The water industry is starting to use our products more commonly as more and more awareness begins to build about how much money they're spending on the pumps that drive that utility. So that's a look at some of our customers. They range down to small chocolate manufacturers that are worried about their mixers getting stuck or broken or process changes.
Interesting. Wow. So taking it from the top here, protecting motors. Okay. I got a question for you. If I'm looking at your load control device and I'm having an issue with the pump in this case, we'll say, do I get some kind of an alert, or does it shut it down? And help me understand the process. So again, if I'm just regular Joe on the street, explain to me how that device works. I mean, it sounds like it's a great tool to prevent catastrophic issues in a plant.
Right. Yeah. So first of all, what they look like, you can see one of them right back here is one of our load controls that we're using to measure this pumping environment.
Yes. Could you go back to a 2-shot so I can see it a little bit larger? I want to see that behind you a little bit more.
Let me just go to the next slide so you can see.
Oh, perfect.
It's the one at 9 o'clock there that you see. That's a pump monitor and control. And so that has 2 ways of communicating with the world. First is as a sensor, it has an output that will relay exactly the horsepower level of the motor that it's connected to and the pump that's connected to. And that could go into a PLC like we have behind me here, where that's going into a process monitoring or some type of control application. And also it has contacts or relays in it as well, so that it can control that pump as well. So you set a high and a low threshold beyond which you want the pump to be shut off. And so that's, you might have the analog output giving you warnings when things start to get high or low, and you might have those contacts or relays in place to shut it off when things become really catastrophic, or that there's something that's happened with that pump, that if it's using that little power, it's probably not pumping fluid and it's going to start to overheat pretty quickly. We'll just shut it off, and then you can come out and reset it and repair it, whatever you need to do at that point.
Interesting.
Yeah.
What else is what other slide do you have here? I'm sure you got some other good visuals.
Yeah, so one of the things I wanted to talk a little bit about was recent use case. This is the town of Amherst waste treatment facility, which is right next door to the UMass Amherst Water and Energy Technology Lab. And we've been working with them for a year now. And I'll sort of walk through 3 different ways we're working with them and see if we can sort of extrapolate that into some other customers as well. But one of the things that happen with these guys is you see here a big waste mixer, aerator that has a rake that's very highly geared, that's spinning in circles constantly. And these things are usually driven by a fairly small motor, large rakes, and the motor spins, it's like 10,000 to 1 gear ratio. So picture you're on your spin bike and spinning as fast as you can for a minute, and you travel about a foot. That's sort of the ratio that's in place for some of these mixers in the water treatment facility. And one of the things that happened is this rake started to go off the rails. It got stuck. It ran up against a concrete a pillar and bent the whole environment. So you see they had to empty it out, had to repair the rake and the mechanism that it's driving it, and fill it back up. Very costly, time consuming, and impacts their capacity to treat waste. And so what our products do is they operate as this electronic shear pin. It used to be this was a piece of metal that would break when and to stop the process when the rake or the motor was stuck. We do it electronically, so we could tell now when that rake is in trouble and needs to be shut off. So that's how we started working with these guys, is just to protect. They've got half a dozen of these. We've got other customers that have literally fields of hundreds of these that we're protecting. But that's how we started with the town of Amherst. And then we moved into their pumping environment, and here's one of their pumps. And this is a pump that they do preventive maintenance on because it deals with a lot of residential waste. There's a lot of cooking oil that's in that waste. And so when the cooking oil begins to adhere and add up, it starts to impact the pump, and they know that they need to take the pump apart and clean it out and put it back into service again. And they were using a pressure meter to do that. And it turned out that the pressure meter that you see here in the picture was also being impacted by the exact same cooking oil. So their sensor to tell whether it was time to fix it or not was not really that reliable, because the same contaminant that was bothering the pump was bothering the meter as well. So because our sensors and controls are installed back in the motor control center, and if you've been in one of those are the rooms that have all the gray lockers that sort of have kind of remind you of your high school days. That's where our stuff is installed. It's away from the fray, right? It's away from contaminants, noise, and any other issues that might impact the ability to read and sense the environment consistently over time. So they were able to replace these pressure sensors with our products, and it's a much more reliable way of measuring the environment and what's really going on there. So we installed our products on a lot of their pumps, a lot of their mixers, aerators, and then the last thing that we're doing. So here's a view of kind of what happens over time. Is this is a power output. The red is sort of the steady state of the power levels depending on as the process changes over time. And what you see in the blue line there is over time, if a pump is doing more, is consuming more horsepower to do what was the same work, it's a sign that your process has become less efficient. So it's a good way of saying, okay, there's cooking oil in this process. We know we need to clean this pump out, because the gap between the red and the blue lines has given us some idea that, yeah, it's preventative maintenance time. And then the third thing we're doing with them is, and the University of Massachusetts Water and Energy Technology Lab, is looking at water quality and the amount of power that's being used by the facility. And it's early days in terms of getting our data out of that. We hope to have a lot more of that done in the coming months, and to publish some papers around that, and to participate in some of the water trade shows going forward with that type of data of how to find an optimal level of energy that your process is consuming for water quality. And we think there's going to have some really significant impact on the water industry based on the ability to understand at an individual device level how much is each pump, each mixer, each sludge collector, each one of these elements of their network of water treatment is really using most of the energy and contributing most to the water quality. So we see this as a really neat way of becoming involved with somebody, first in protecting their motors, then optimizing their motors, getting a little bit into predictive maintenance, and now into energy management. And I think in a lot of ways that kind of mirrors where we are as a company and what our customers are doing as well, that they have the motor protection, the pump protection down, and now they're looking at other ways to leverage that exact same data to make their operations more efficient.
Interesting. Do you actually have these KPIs that I'm seeing, the charts and graphs, the speedometer?
A little bit quiet. Do you mind? Can you repeat yourself?
The KPI that I'm looking at, these charts and graphs and so forth, are these part of the output of your devices?
Yeah, so these are you'll see the speedometer that's coming directly from our products. The time stamping is done through some of the dashboards that the researchers at UMass have put together. But all the source data, the true power, the power factor, that's all coming from our devices. Yes.
Let's go to the next part of your slideshow here. I mean, this is fascinating information, Mike. And I'm going to ask you that one question. Give me an example, a real world example where you charged in and saved the day at a particular company, but you're already doing it. I mean, you're doing it right here. So this is great. I mean, so I see your product right there.
Yep. So yeah, here's a view of the pumping center of excellence that we built, that we talked a little bit about early on. That's part of it's behind me. And one of the things we wanted to do was look at some future developments of power sensing and how it can be more applicable to predictive maintenance. And so we wanted to build an environment that let us build a real world pumping environment, pumping water. We've got a bunch of different pumps and motors from our different partners. Some of them are waiting to be tested. Some of them are already been broken and are behind us. And so the goal here was to fully instrument an environment and be able to get a sense for the relationship between performance and energy and what's being used. And it's also led us down sort of an interesting path as well, and a new product that we're working on that I wanted to sort of give some sort of a preview into that as well. So that's the pumping environment. You can see part of it is the University of Massachusetts crimson red there. And one of the areas that we're looking at is really exciting for the future of our business, and we think the industry, and it's in the area of electrical signal analysis, signature analysis. Sometimes it's referred to as motor current signature analysis, sometimes as instantaneous power analysis. And the thought here is we capture the wavelengths of the voltage and the current and the power that these motors and pumps are consuming. And it's done the units are over time, right? You can see the sine wave of the voltage and the current. But if you convert that into a frequency, you can actually get a very interesting signature of that process, the motor and the pump or whatever is attached to that motor. And it's essentially the voice or the song of that process. And what you'll see in it are some spikes around the delivery frequency of the electricity. In our case, in the United States, it's 60 cycles per second. But then you also start to see some other glitches in that frequency view, that waveform. And a lot of times those can indicate just power quality, either good or bad things about the power quality, but a lot of times they can indicate what's going on in that process as well. And so what we're starting to do is gather tons of information from this environment behind us through some new products that we're working on, and starting to analyze those waveforms to start to understand that a glitch in this waveform might mean a bearing is starting to fail, or there's a short in one of the windings of the motor, or the rotor itself has a break in one of the magnets itself, or there's an imbalance, or there's something happening with the pump impeller. And so we're starting to gather a lot more information about what those types of failures look like. That's why I talked about breaking pumps and motors. That's what this environment is about. So you can see the new product up there on the right, very simple to install. It's about the size of a couple of decks of cards. And that's what's gathering those signals that we're doing this analysis of. And it's an interesting sort of, we hear a lot in the world about artificial intelligence and machine learning. And this is sort of an interesting intersection of that and an expert system where there are consultants and partners that we're working with to help to analyze those waveforms and better understand what it is that we're seeing and interpret that data. But I believe over time, as the price of computing continues to go down and the sophistication and maturity of artificial intelligence, machine learning algorithms, as those continue to expand and get better, that we're going to be able to do more and more on these small devices that live out next to pumps and out next to motors. And so that's what we're looking at here at Load Control. So it's really for a fun time in the company evolution, that we've got lots of really good customer things going on, lots of great applications. We're in some really exciting businesses. And also starting to work on some of these new future directions for the company and the industry.
So in a way, it's sort of like an EKG. You're analyzing if the pump is the heart, if you will, and you're kind of looking at the analytics like an EKG, right? I mean,
yeah, that's it.
Yeah, there you go. Right, that fell right into place.
Yeah, I mean, this is, so for each one of the three phases, you have usually three phases that feed electricity into an industrial motor. This is just one of them. We're able to look at the voltage and the current, and then do that EKG, that wavelength of what's happening from a frequency perspective. And you see, in this case, this is running off a variable frequency drive that's at 50 hertz or 50 cycles per second for the electricity. And you see some spikes at 50, and then some harmonics of that up the line. But then you also see other things happening in that bottom right curve. And so that's what we're doing here, is starting to dig into that bottom right curve and look at both current and power signals for what's changing in the process and what do those changes mean.
All right, so let me throw a question out there for you. When you're using a VFD and it creates an arc between the bearing and the shaft, and you can see evidentiary, almost EKG etchings on the bearing itself, all right, on the actual or on the shaft, or somewhere where the connection between the motor and the pump is, that area, you can see that signature on the actual metal, right? When you're detecting that kind of micro arcing that starts to etch, does it tell you that, or does it give you that warning that this is happening and therefore you need to bleed off that electrical arcing with a brush or something like that? Or how does that work?
Yeah, so right now where we as a company are is we're gathering a lot of this data and trying to identify those different patterns. And then we have partners out there that we're passing that information on to, that are in that predictive maintenance world. In some cases, it's a true expert system where they're looking at the data that we're passing to them, and they're getting experts involved to look at that data, and then they're telling the customers that have signed up for that subscription for predictive maintenance, hey, this appears to be happening. The nice thing is, the way this works is we're getting very early. We've got very fine-tuned ability to look at these problems and diagnose them much further in advance than, when you start to get a temperature or some type of a mechanical evidence that this failure is happening as well. So that's the goal of this type of analysis, is to catch those errors, those faults much sooner before you see some type of physical evidence that it's happening.
Okay, I love it. So if I can put on the old guy hat for a minute,
Yeah.
I recall, and you can go back to a two shot if you're okay with that. But my
Yeah.
understanding is back in the day, people would take a screwdriver and put it against the pump and kind of listen to it, or a motor, right? Right. I mean, that's about all we had
Sure.
back in the old days, right?
Yeah.
And usually by the time you're hearing an issue, the damage is done. So I think
Right.
that this actually can help you. Uh, I don't want to say mitigate. Well, I guess mitigate what the damages that may occur, with lubrication, or again, if you're having some kind of arcing issue or something like that. I guess.
Yeah. Yeah, no doubt. That sort of arcing, that type of a shorting in a motor winding is the type of faults that this motor current signature analysis, electrical signature analysis is designed to be able to detect very early on in the process. So don't need to put a screwdriver next to it.
Yeah.
And I think, one of the things that's nice about this is, in many ways, these are ways of getting more out of products that you have in place to protect your motors, right? You wouldn't install a magnetic drive pump with having some way of ensuring that there's flow happening in the pump, right? If the flow stops happening, that heats up very quickly, and you have a maintenance issue. You might have something all over your factory floor. So that's where a lot of our products are installed today, is in basic pump protection. And what we're looking at are ways that we can say, okay, if we already have that data, why at the same time wouldn't we be looking at how much more or less energy that pump and motor are using over time to give you more efficiency information, and also looking at the signature of that electrical connection that we've already made, to say, is that changing over time, and is there a maintenance issue that you should be starting to address or looking at to the next time you're around looking at that pump or motor. So to
Right.
me, this is just great ways that we can take power sensing and make it more relevant, so it starts to become a more prevalent way of sensing what's going on with motors and pumps.
Well, and ultimately, you're building more value with your customer base. I mean,
Right.
if you, as we follow that evolutionary process of what you started off with and now where you are, I think any client would look at you as a consultative resource that could actually benefit them. And
Right.
where you start off with something that can shut a pump down if it's being stressed, and now you're actually getting predictive, or I don't want to say AI, but you're getting in that zone where you're predicting an outcome well in advance, and then helping to modulate energy consumption too. I mean, significant value there, just
Yeah.
to your existing customer base.
Right.
But I would imagine it kind of lends itself to even uh, newer clients that are out there that are heretofore untapped resources.
Yeah, I think a lot of, so the reason we sort of got pulled into this was our customers. They're the folks that had these ideas. We didn't come up with this in Sturbridge. We're just working to implement their good ideas. But yeah, that we think it will open up a new customer base for us as well. You've seen the numbers that 2/3 of all the world's energy is being used by industrial motors, and the largest piece of that is in that sort of 1 to 500 horsepower motor space where we play. And to me, our ability to have solutions to help impact that sort of carbon footprint, that type of energy production, that's a great thing for everybody if we can continue to get better at that.
Well, Mike, usually on these lunch and learns, I love to ask this. So if you have an analogy or a story, you don't have to name the customer, but let's just say it's a noteworthy instance where somebody called and said, "Look, I don't know what's going on. I need your help." And if you could just kind of lay out a story of how you or one of your team went into this facility, and maybe it was challenging. Maybe you had to do some investigative work, and then you know implemented your product, and everything's great now. I mean, can you give us a story like that? I love to hear stuff like that. So
Yeah, sure. There's one sort of upstate New York that comes to mind just because of the environment that they're in. These guys are making it's a chemical factory, and the chemicals that they're making are just highly explosive. And so they really had no way of monitoring the pumps. And when fluid stops flowing, it creates sort of an electric charge and can make the environment incredibly explosive. And so they needed to monitor pumps to ensure that fluid is going through the process. And also at the same time, they couldn't really install something on the pumps or on the motors that had any sort of electrical connection like that, because of the likelihood that that could create an explosion in itself. So the beauty of our products is they're installed back in the motor control cabinet, away from the room that they're processing this lye, and it allows them to monitor the environment in a way that they were unable to. And so it's really raised the whole safety level of their factory in a way that there were really no other solutions to it. So that's one sort of explosive example. We've got a lot of ours in the food and beverage industry as well, where our products are protecting pumps that are pumping products that are being mixed together, pumped together and mixed together, where they're using our products not only to protect the pumps and understand that the flow is there, they're measuring viscosity in a way that they don't have any other way of doing. So we've got a lot of sort of interesting use cases like that, where Oreos, where they're mixing together the cream and the sugar, and they have the ability to understand the viscosity of our products. So we've got tons of great use cases like that. And I think that's one of the things that's nice about load controls, and the sort of personal touch that we take to our business is, if you have a problem with our product, you pick up the phone, you'll be talking to an engineer. It's the only people we have. You can get directly to all of us. It's still very much a application and user-driven company that you're going to get somebody that can help you with your problem, because we've been in the industry for 38 years. And so we've done hundreds of thousands of these out in the world, and we've seen everything before. And so that's one of the things we really pride ourselves on, is having the ability to help our customers get the stuff up and running quickly. Our products are designed, they're really, really simple to implement. We joke we have 4-page installation guides for all of our products. In an era of 47 and 200-page installation guides, we find that our customers really like that. We've always had the mantra, keep it simple, and that definitely is the way we operate as a company. And so that's sort of an interesting sort of mixture of keeping things simple, but at the same time doing some sort of leading edge research, working with universities and some pretty exciting consultants on this whole electrical signature analysis stuff. So it's a fun time to be here at Load Controls.
Well, and this whole setup you have behind you, working with the university and all, that's a fairly new connection there with you and the university, right? I mean, that's within the past year, within the past 6 months, maybe, right?
Yeah, we started about 2 years ago. I have a buddy that's in the state of Massachusetts water industry, and he sort of got me connected into there. And now we've got lots of things going on. We're doing some of the electrical signature with them. They're helping us with 3D printing for our prototypes. We're instrumenting the town of Amherst water waste treatment plant for doing all the water quality stuff we talked about. And it brings a great sense of energy to the building as well. We've got students coming through here, researchers coming through here. We're spending time with them. It's always great to see fresh ideas on problems, and that's been just a great thing for the company.
Yeah, that's incredible. Let me ask you two questions. I couldn't let this whole conversation go by without sharing with our viewers two things. One, where can they see you? And I mean that in that, where are you going to be next? Are you going to be at any shows, any trade shows, either internationally or in the US? And the second part of that question is, how do people get a hold of you or load control? So why don't you start off with, are you going to be at possibly a trade show in June somewhere, anywhere?
Yeah, we'll be at WEFTech this year. That's the one we've
WEFTech?
spent most time around, because there's a lot of pumping conversation there.
Fantastic.
Yeah, and we do a lot
WEFTEC's
of,
a big show.
yeah, it is. We found for our markets, what they like is to have a lot of technical information and tools out there that they can make their own decisions. They can research different applications and solutions we have. So we put a lot of resources into LinkedIn advertising and Google advertising. We still advertise, and we have a great partnership with Powering Pumps as well, as you know. And we put a lot into loadcontrols.com. So that's where I would say we get most of our activity, most of people researching our stuff. So if you just Google pump power sensor, pump power control, you're going to find on that first page 10 results. 7 of them will be about load controls, or just go to loadcontrols.com. You'll see plenty of information out there. And then we'll start to, as we get some of the data back from the water quality study, we'll participate in some more pumping trade shows around that as well, and get out there.
If I could, shameless plug here.
Yeah, let's do
I'm
it.
looking at our partner hub, and the first business card on the hub here is load controls. So of course you can always reach us at Empowering Pumps and go to the partner hub, and there's a little bit more about load controls here, and a white paper and all kinds of fun things. So definitely. And WEFTech is, the big show. Let me ask you this: do you service people internationally?
We do. We sell our products directly ourselves. You can buy them off of our website. We work through about 350 global pump distributors that service our products, that sell and install and service our products worldwide. And then we've got thousands of electrical consultants that we work with as well, that can install our products as well. But we do sell internationally. We sell both RoHS, lead-free, as well as for US markets. And so we do plenty of international business as well. Yeah.
Well, I'm impressed. Again, founded in 1984, over 150,000 installs.
That's right. Yeah, we're about 170,000 at this stage. So
Wow.
We've got a lot of products out there. I think, it's been a great business. It's one that we hope that continues to expand, and people find new applications for measuring motor power.
Wow. Well, Mike, I got to tell you, it's been a real joy to get you on the Lunch and Learn and hear a little bit more about load controls and what you have to offer. I think it's a valuable tool. And if anybody listening in needs to get in touch with you, I guess the best way to do it is to Google load controls, or go to Empowering Pumps and look you up. And do you have an email that also we put that in the notes down below in YouTube?
Yeah, well, just sales at Load Controls always works. I'm Mike at Load Controls. com. Not complicated at all.
No,
So,
I,
yeah,
that's the beautiful thing about your company is I can call you. I mean, I can call
yeah.
you and you're there. It's very quick. You just
Yeah, we have
amazing.
some of the worst phone screening technology in the world, which means you're going to get me or you're going to get one of the engineers when you come
Yeah.
in here. And
Well, if
that's
I'm
on,
gonna
right.
if I'm a client and I'm doing business, that's the kind of company I want to be able to get you very quickly if I need something. And I think that's a testimony right there that you're here to help and you got a great product. So
Yeah.
awesome.
Well, it's been a lot of fun. It's been great working with you guys in Empowering Pumps. Appreciate the time, and it's always great to talk to you, Vince.
My pleasure. Thank you. And
All right.
folks, if you like what you saw here, be sure to like and share. Again, I'm Vince Marino with Empowering Pumps and Lunch and Learn with Vince and Mike McClurg. I've got to tell you, this has probably been one of the best Lunch and Learns I've done in a long time. So thank you for joining us.
My pleasure, Vince. Thanks. Take care.